All right, and this is our last video for lecture 12. We will just do modeling. And in these problems, the first ones you are given the equation, and in the second ones you're given 2 points. So those are very, very similar to the problems you've already been doing. The third type, instead of being thrown the slope and a point or something like that, I throw you a story. And with the story, you need to come up with an equation. So that makes that type a little bit different. And in all three of these problems, I'll be asking you a lot of questions. So we'll start. First of all, dependent versus independent variables. I always ask the question and nobody's ever thought of it. I say, have you ever wondered? And nobody ever wonders. But in case you had ever wondered why, in the newspaper, and you see a little graph or whatever, why one variable is on the horizontal axis and one variable is on the vertical axis. It's actually not just flipping a coin to see who goes where. It's for a very specific reason. And that reason is that one of the variables is viewed as being dependent and one is viewed as being independent. So one depends on the other. The y-axis is the dependent variable. It's what's being predicted. It's the result. Whatever's on the x-axis, that's what's being used to predict, or that's the cause. So if we look at these following pairs of variables, all of them are related. Your height and weight are related. The crime level and what year it is related. All those things are related. But one of those is independent and one of those is dependent. So if you think about your height and your weight, does your height depend on your weight, or does your weight depend on your height? Well, your weight doesn't completely depend on your height, but it does a lot more than the other way around. So height would be independent and weight would be dependent. If you were to graph height and weight on a graph, height would go along the x-axis and your weight would go on the y-axis. Okay, let's say you jump in a car for a road trip and you're driving a certain speed and you go a certain distance. Does your distance driven depend on your speed, or does your speed depend on your distance driven? Okay, the distance driven depends on your speed. So speed is independent and distance driven is dependent. Crime level and year. Okay, crime level depends on the year. The year doesn't depend on the crime level. So year is independent, crime level is dependent. Okay, the month and the ice cream sales. Ice cream sales depend on what month it is for the most part. So ice cream sales is dependent and the month is independent. How about an athlete? How many points he scores in a game and how much time he has in the game. Okay, how many points he's able to score depends on how much time he's able to play. So time in the game is independent and points scored is dependent. Electricity used and your electricity bill. Your bill depends on your usage. So we have independent is usage and my bill is dependent. Okay, and so the problems are of three types. I've already told you those. You'll just answer questions. You'll get an equation from points, or you'll get an equation from a story. And in all of these, you'll be answering questions. When you get to the interpret questions, please interpret in real life terms. I don't want you talking to me about a slope or an intercept or whether something's like a slope is increasing or rise over run. I don't want to hear any of those terms. I want to hear, what the taller somebody is, if for every minute a player is in the game, he can score an average of one more point or something like that, where it really makes sense in real life. Okay, so let's do this first one. The electric bill charge for a certain utility company is that per kilowatt hour. The total cost Y depends on the number of kilowatt hours X according to the equation Y equals 0.095X. Now here I could have had you come up with the equation. You actually do have enough information, but I didn't. I gave you the equation. Which of those variables is independent? The number of hours or your bill? Well, that's a pair we've already talked about. The independent is the number of hours I use, and the dependent variable is the bill, which is Y. X is the number of hours used, it's independent. My bill is Y, and it's dependent. Okay, for C, D, and E, I've got a number. I need to figure out whether I want to plug it in for X or for Y. That's as hard as it gets. It's pretty easy. So determine the cost of using 1,000 kilowatt hours. Well, do I want to take 1,000 and put it in for X or Y? Well, since X is the number of kilowatt hours I use, I want to put it in for X. So I say Y equals 0.095 times 1,000. I put it in for X, which is 95. Now, the only way you might miss a couple points here is if you forgot to put the units. So I'd say my bill is $95. Make sure your units are on there. Now, determine the cost of using 2,000 kilowatt hours. Same thing, put it in for X because I'm measuring kilowatt hours. Simplify and don't forget your units. So my bill is $190. Now my bill is $128.25. How many kilowatt hours did I use? Where do I put 128.25? Well, that's the bill. That's Y. So I put it in place of Y. And notice the question says, how many hours did I use? It's asking about X. So I know it's not, I don't have X. Okay, divide both sides by 0.095. And I get X is equal to 1350. Determine the y-intercept and interpret. Oh, and it would be 1350 hours. Don't forget your units like I just did. Okay, for the y-intercept, two ways of finding the y-intercept. The first is just to look at the equation. Since there's not a number after the 0.095x, there's nothing there. It's just like having a 0. So my intercept will be 0. The other way, remember when I find a y-intercept, I let x equal 0. If I plug that in, I still get 0. Either way you look at it, my y-intercept is 0. Now for the interpretation. What does that mean? Don't tell me that's where the graph crosses the y-axis. What does y equals 0 mean? I just put 0 in for x and I got out 0 for y. What does 0 for x mean? That means I don't use anything. So if I don't use anything, then my bill is 0. So that means if I have used 0 hours, my bill is $0. Determine the slope. That's just the number in front of x. So that means for each hour I use, I pay 9.5 cents or $0.095. Now here are a couple of things just to help you, little hints. So for the intercept, if x equals 0, take the real life interpretation of what it means for x to be equal to 0. So if x equals 0, that means I use 0 hours. If I use 0 hours, then y equals the y-intercept. Y equals 0. My bill is 0. Put the real life interpretation in place of those parentheses. For the slope, again, you put the real life interpretation in place of these parentheses. If my usage increases by 1 hour, then my bill increases by 9.5 cents. Okay, now on to the next one. Okay, here is our second example. The figure, which I lost in my computer somewhere, but you don't need it. So there used to be a graph here. Depicts a relationship between a person's height in inches and the length of a person's arm, also measured in inches between their shoulder and the wrist. Use the points 17, so it's a 17-inch arm length, and then the height of 57.75 inches. And another point, so this is another person with a 24-inch arm length, and they are very tall at 82.25 inches, to find a linear equation relating the height to the arm length. So here, this is just what we've done over and over and over again. You have 2 points. You need to find the equation of the line between those 2 points. No matter what information you're given, what do you do first? First thing is to find the slope. So we take y minus y over x minus x. Simplify, and we get 3.5. Okay, the next thing we do, if we're going to do method 2, we'll take y minus one of the y values. I just used the first point, but it doesn't matter. Equals slope times the x minus the other x value. Okay, multiply through, combine like terms, and we have y equals 3.5x minus 1.75. Okay, what is the slope of that line? Well, the slope of that line, where do I need to look? As long as I have y solved for, as long as I have the line in slope-intercept form, I look right in front of the x, so my slope is 3.5. What does that mean? Go back to what was written on the last slide in red. How do we interpret slope? Okay, that says when x increases by 1, what is x? X is my arm length. So if my arm length gets 1 inch longer, then y increases by m. What is y? Y is the height. It increases by 3.5 inches. So when arm length increases by an inch, you can expect height to increase by 3.5 inches. Notice I didn't mention anything about slope or rise over run. It's a real life interpretation. Okay, use the equation to estimate the height of a person whose arm length is 21.5. Where do I put 21.5? Do I put it in for x or for y? Well, since x is the arm length, I put it in for x, do the math, and it comes out at 73.5. So I would guess that they're going to be 73.5 inches tall. Okay, third example. A bakery that specializes in bread rents a booth at a flea market. The daily cost to rent the booth is $100. Each loaf of bread costs the bakery $1.50 to produce. Notice that both of these are costs. So they pay $100 to rent the booth, and then they pay $1.50 for each loaf of bread because they have to pay to make the bread. So write a linear equation to compute the total cost if X loaves of bread are produced. There are two ways to do this. The first is to just look at the data and say, okay, let's look at what happens if they sell no bread, if they sell one loaf of bread, if they sell 2 loaves of bread, and try to see a pattern. The other way is to just look at it logically and just try to come up with the equation. So we'll do both ways here. First of all, just looking at the data. Let's just list the cost for these different scenarios. If I have 0 loaves of bread, then it's $100. If I sell 1 loaf of bread, it costs me $100 to rent the booth, and then it costs me $1.50 to make that bread. So it's $101.50, but I want to write it this way for a very specific reason. $101.50 doesn't help me see the pattern, but this will. If I sell 2 loaves of bread, I spend $100 for the booth, and then I spend $1.50 twice for the loaves of bread. If I sell 3 loaves of bread, then I pay for the booth and I pay for 3 loaves of bread. If I sell X loaves of bread, I pay for the booth, and then I pay $1.50 for each of the X loaves of bread. Okay, the logic behind that, if we look at that, it's my cost is going to be $100 for the booth, and then it's $1.50 for each loaf of bread. That's how $1.50 is how quickly my cost is increasing. So it's $100 for the booth plus $1.50 for each loaf of bread. So I take $1.50 times the number of loaves of bread, and I could just get the equation directly. Let's answer a few questions about our bread booth. What would the total cost for one day be if I sell 175 loaves of bread? Where does 175 go? In for X or for Y? Well, it goes in for X because X is bread. Figure it out, and I get $362.50. Okay, how many loaves of bread were produced if my total cost was $8.50? Notice it says how many loaves of bread. It's asking about X. It gives me the total cost, which is Y, so I put $8.50 in for Y, solve for X, and I get 500 loaves of bread. So those are our 3 types of modeling problems. Good luck, and I will see you next time. Oh, last problem, sorry, we were almost done. What is the y-intercept? The y-intercept is 0, 100. That means even if I make no loaves of bread, I have to pay $100. So go back to what the intercept interpretation was. If x equals 0, if no bread is sold, then y equals b. Then my total cost is $100. Okay, now I think we're done.